There are a lot of branches of mathematics that are known to men, also known as the language of numbers. It means many things to many people. Some may know it as a useful tool that is a key to getting civilizations rolling. But to others, they find it as an academic nuisance that only serves to lower grade transcripts. Still, what can't be denied is that mathematics is here to stay, and it is actually a part of our lives, even down to the most basic things. One of the foremost branches of mathematics is calculus. The formal study of calculus started from the 17th century by well-known scientists and mathematicians like Isaac Newton and Gottfried Leibniz.
Although it is possible that it has been not used as early as the Greek era, it is a mathematical discipline that is primarily concerned with functions, limits, derivatives, and integrals, just to name a few.
This discipline has a unique legacy over the history of mathematics. Even though it is split between the two definitions of Newton and Leibniz, it has still been able to create a new mathematical system and was used in a variety of applications.
There are two different fields of calculus. The first subfield is called differential calculus. Using the concept of function derivatives, it studies the behavior and rate on how different quantities change. Using the process of differentiation, the graph of a function can actually be computed, analyzed, and predicted. The second subfield is called integral calculus. Integration is actually the reverse process of differentiation, concerned with the concept of the antiderivative. Either a concept or at least semblances of it has existed for centuries already. Even though these two subfields are generally different from each other, these two concepts are linked with the fundamental theorem of calculus. Though it is complicated to use well, calculus does have a lot of practical uses that you probably won't comprehend at first.
The first one is, banks use calculus to estimate the amount to be paid by their clients to achieve a desired interest rate. They use limits to compute an amount that would be fair to satisfy both parties.
Good morning, sir. What can I do for you today?
Good morning, ma'am. I would like to ask you, how can I increase my interest rate?
Oh, you can increase your interest rate by increasing your monthly deposit.
What is the possible amount of money that I need to deposit?
So last time, you signed up for 5K to 10K a month. You can change it into 5K to 30K to increase your interest rate from 5% to 10 to 15%.
Oh, okay. Thank you for your service, ma'am.
In the video, the client is asking how much he would have to pay to get his desired interest rate. After computing, the teller offers an amount that his client has to pay to achieve that interest rate. With the use of limits, the teller and the client has come to an agreement that would be beneficial for both of them. Let's go on to the next example. Crime investigators and lawyers use calculus to conclude evidence. Because the CCTV footage was broken, investigators can deduce the possible scenarios that would have taken place during that time by applying the basic principles of calculus.
Lawyers can use calculus to form different hypotheses when CCTV footage get technical problems.
With the help of calculus, justice can be served for the family of the victim. For the last example, in order for doctors to prescribe the correct dosage of a drug and provide a regimen for treatment, the drug's concentration over time must be tracked. This prevents under and overdosing. The way that a drug's concentration over time is calculated using calculus. Yes, you heard it right. In fact, a drug's course over time can be calculated using a differential equation. In applications of differential equations, The function represent physical quantities and the derivatives, as we know, represent the rates of change of these qualities. Therefore, a differential equation describes the relationship between these physical quantities and their rates of change. In order to create a differential equation that describes the physical quantities of a drug in relation to the rate at which they change, let's consider the following variables. D represent the drug dosage in milligrams. C, the concentration of the drug at any time. T, time in hours since consumption of drug. That's all for today. I hope you learned something new. Always remember that math is everywhere.